26 AD, a craftsman walked into Emperor Tiberius's palace in Rome. He carried a glass cup. He placed it on the marble floor and dropped it. It didn't shatter. It dented, like metal. He picked it up, bent it back into shape, and handed it to the emperor. Tiberius asked one question: "Does anyone else know how to make this?" The craftsman said no, only him. Tiberius had him executed on the spot, not out of fear, out of calculation. Because if unbreakable glass existed, gold and silver would lose their value overnight. The formula died in that room, and for 2,000 years, we assumed the story was fiction. Then scientists tested a fragment of Roman glass in a London museum and realized it wasn't fiction at all. Today we are looking at 7 ancient technologies, not mysteries, not myths, technologies, with working mechanisms, measurable results, physical evidence sitting in museums right now, technologies that should not have existed for another 1,000 years, and in some cases, 2,000. A lens ground to optical precision, 3,000 years before Galileo built his first telescope. A battery producing measurable electric current, 2,000 years before Alessandro Volta. A naval weapon so devastating that the empire which created it chose to die rather than share the formula. And a food preservation system so effective that NASA quietly adopted it in the 1960s, without mentioning where it came from. 7 technologies, 7 suppressions, and one question that runs through all of them. If they knew this, what else did they know? 3 separate Roman historians documented the same event: Pliny the Elder, Petronius, Cassius Dio, an emperor destroying a technology to protect his economy. Pliny described the glass as flexible, unbreakable, capable of being bent without shattering. He called it vitrum flexile. Modern materials scientists have one immediate question: how? Because flexible glass requires specific temperature controls and precise chemical additives. We only developed in the 20th century. In 2012, researchers at the University of Erlangen cross-referenced the Roman historical accounts with modern materials science. What they found was uncomfortable. The mineral compounds the Romans described adding during glass production are exactly the additives modern chemistry uses to produce flexibility in glass. Not approximately. Exactly. The craftsman didn't stumble onto this by accident. He had a formula, a repeatable process, a technology. And Tiberius understood immediately what it meant. Rome's monetary system ran on precious metals: gold, silver, bronze. An unbreakable alternative material would collapse the economy overnight. So he made a calculation. One man's life versus the stability of an empire. The formula died in that room and took 19 centuries to rediscover. But what do you bury a technology to protect, when the technology itself is how you see the stars? The answer was sitting in the British Museum for 150 years, labelled as a decorative ornament. In 1853, British archaeologist Austen Henry Layard excavated the ancient Assyrian palace of Nimrud in Iraq. He found a small oval piece of rock crystal, logged it as decorative, sent it to the British Museum, where it sat for 150 years, labelled as an ornament. In 1999, Italian scientist Giovanni Pettinato was studying Assyrian astronomical records. He came across a description of a lens used for magnification. He tracked it to the British Museum, requested a closer look at Layard's crystal. The optical analysis revealed one thing immediately. The Nimrud lens is ground to a specific focal length, plano-convex geometry, one flat side, one curved side, calculated to bend light at a precise angle. Focal length, approximately 11 centimeters. Hold an object 11 centimeters away. It magnifies. This lens is 3,000 years old. Galileo built his first telescope in 1609. The Nimrud lens predates it by 2,600 years. This explains something historians never fully understood. Assyrian astronomical records are extraordinarily precise. Stars, planetary movements, celestial events catalogued with accuracy impossible for the naked eye. For years, historians assumed exceptional eyesight or exceptional patience. The Nimrud lens suggests a third option. They had help. The British Museum label now reads, possible use as a magnifying lens. Possible. 150 years as an ornament. One question from one scientist. And suddenly, possible. The next technology didn't watch the Earth from above. It listened to the Earth from below, and it worked. In 132 AD, Chinese scientist Zhang Heng presented Emperor Shun with a bronze vessel, 2 meters across, 8 dragon heads around the outside, each holding a bronze ball. Below each dragon, an open-mouthed toad. Zhang Heng's claim was simple. When an earthquake strikes anywhere in the empire, one dragon drops its ball. The direction it faces is the direction of the quake. The court officials smiled politely. Then, in 138 AD, the Western dragon dropped its ball. Nobody had felt anything. No reports, no messengers. The court laughed. Days later, a messenger arrived from the west, reporting a major earthquake, from exactly the direction the dragon had indicated. The device is called the Hufeng Didong Yi, the world's first seismoscope. It worked on a suspended pendulum mechanism. Seismic waves swing the pendulum. The pendulum triggers a mechanical release. The ball drops. This is the same principle used in modern seismographs today. Zhang Heng built a working version in 132 AD. The modern seismograph was officially invented in 1880, a gap of 1,748 years. Here is what makes this different from everything else on this list. Zhang Heng's device was never destroyed, never confiscated, never mislabeled. It simply disappeared after he died in 139 AD. Nobody wrote down how it worked while he was still alive. In 2005, Taiwanese scientists spent 3 years reconstructing it from historical descriptions alone. It worked. The most expensive knowledge in history is not what was destroyed. It is what nobody thought to write down. This next technology was written down in detail, and NASA read every word, without telling anyone where they found it. In 1962, NASA needed to solve one problem. How do you feed astronauts in space? Their solution, 3 years of research, was freeze-drying. Remove moisture under low pressure. Food becomes lightweight, shelf-stable, nutritionally intact. NASA called it a breakthrough. What they didn't mention, the Inca had been doing this for 2,500 years. High in the Andes above 4,000 meters, the Inca developed chuño, potatoes left in overnight freezing temperatures, exposed to intense daytime sun, trampled to remove remaining moisture, repeated over several days. Result, a completely dehydrated potato, storable for up to 10 years. No refrigeration, no chemicals, no additives. Modern food scientists confirm the process works because extreme Andean temperature variation combined with low atmospheric pressure at altitude creates the exact conditions for freeze-drying. The Inca didn't stumble onto this. They engineered it, selecting specific potato varieties, timing to specific seasons, storing in precisely constructed underground chambers. This was a food technology system sophisticated enough to feed armies on campaign, supply cities through drought, maintain strategic reserves across a 6,000-kilometer empire. When Spanish conquistadors arrived, they found Inca storehouses with chuño decades old, still edible. The Spanish documented it, sent reports to Europe. Europe filed them away for 400 years. NASA's freeze-drying patent, 1966. Inca chuño system, 500 BC, identical in principle. The credit went to the 20th century. The next technology wasn't hidden in archives. It was in a museum, while scientists walked past it every day, assuming they already knew what it was. They were wrong, by 17 centuries. In 1938, German archaeologist Wilhelm König found a small clay jar in the National Museum of Iraq, 14 centimeters tall. Inside, a copper cylinder. Inside that, an iron rod, separated by an asphalt stopper. König recognized it immediately. Not from archaeology, from physics. A galvanic cell, a battery, 2,000 years old. He published his findings in 1940. The archaeological community called it a storage vessel for sacred scrolls. König pointed out the dimensions made scroll storage physically impossible. They revised the explanation. Storage vessel for something else. Nobody specified what. In 1940, American engineer Willard Gray built an exact replica, filled it with grape juice, connected a voltmeter, 1.1 volts of electric current. He published the results. The community acknowledged the experiment and kept calling it a storage vessel. In 1978, Arne Egebrecht of the Roma and Pelizaeus Museum built another replica. Used the current to electroplate a silver statuette with gold. Successfully. Electroplating was officially invented in 1805. Egebrecht demonstrated it using a 2,000-year-old clay jar. He then examined ancient Parthian artifacts from the same region. Several showed evidence of thin metal layering consistent with electroplating. Similar jars have been found at multiple sites across the region. Same period, same configuration, all classified as storage vessels. 3 independent experiments. Same result. 80 years. Official classification unchanged. Some suppression needs no conspiracy, no emperor, no colonial power, just a wrong label, left on a shelf, where everyone can see it, and nobody has to explain it. The British Museum acquired this cup in 1958. Roman, 4th century AD. Carved glass depicting a Greek myth. Beautiful, decorative, unremarkable. That was the label for 30 years. In 1990, museum scientist Ian Freestone examined it under an electron microscope. What he found inside the glass should not have been there. Nanoparticles. Gold and silver particles ground to between 50 and 100 nanometers in diameter, distributed uniformly throughout the glass. A nanometer is 1/1000th of a meter. The technology to manufacture particles at that scale was developed in the 20th century. This cup was made 1600 years earlier. But the nanoparticles are not decorative. They are functional. Light passing through from outside. The cup appears green. Light from inside. It turns blood red. The gold and silver nanoparticles interact with light at the quantum level, producing different colors depending on the direction of illumination. This is called plasmon resonance. The same principle used today in nanotechnology research for medical diagnostics and optical sensors. Roman glassmakers were using it to make a drinking cup change color. The nanoparticle distribution was too uniform to be accidental. Someone knew exactly what they were adding, and exactly what it would do. The British Museum updated its label after 1990. The cup is now described as a rare example of Roman cage cup work. The nanotechnology gets a footnote. 1600 years ahead of its time. A footnote. The last technology on this list received no footnote, no label, no archive, no museum display. It was protected so completely that when the empire fell, it vanished from human knowledge entirely. In 678 AD, an Arab fleet sailed toward Constantinople. Thousands of ships, the largest naval assault in Byzantine history. Every calculation said the city would fall. Then the Byzantine ships opened their bronze tubes, and the sea caught fire. The Arab fleet was destroyed almost completely. Survivors reported the fire could not be extinguished with water. Water made it burn harder. It clung to wood, to rope, to skin. It burned underwater. Greek fire saved Constantinople in 678. again in 717, again in 941. For 300 years, no navy on earth could challenge Byzantine sea power. The Byzantines shared the formula with no one. Not allies, not trading partners, not their own land generals. Only the imperial family and a small group of designated chemists knew it. Emperor Constantine VII wrote explicitly, "The formula must never be shared with any foreign nation, under any circumstances, for any reason." Modern chemists have spent centuries trying to reverse engineer it. Historical accounts suggest quicklime, possibly naphtha, possibly pine resin. Every reconstruction burns. None burn underwater. None intensify with water. None match what 12 centuries of accounts describe. In 1453, the Ottomans broke through Constantinople's walls after 1100 years. The imperial family was gone. The chemists were gone. The formula was gone with them. Unlike everything else on this list, Greek fire was not mislabeled, not misclassified, not buried in an archive. It was never written down, by design. The most effective suppression in history is not burning the documents. It is never creating them. And when Constantinople fell, the sea stopped burning and has never burned again. 7 technologies, 7 endings, 1 pattern. Someone knew, and then decided you shouldn't. An emperor chose his economy over an invention. A museum spent a century and a half calling a telescope an ornament. A court forgot to write down how their earthquake detector worked. A colonial power filed away 2,000 years of food science for 400 years. 3 experiments proved a clay jar produced electricity. The label never changed. A drinking cup contained nanotechnology. It got a footnote. And an empire took its greatest weapon to the grave, deliberately. These are not conspiracy theories. These are objects you can visit today. Touch the display case, read the label, and ask yourself how many other labels are wrong. The pattern is not ignorance, it is decision. Someone looked at each of these technologies and calculated that the world was not ready, that the knowledge was too dangerous, that the timeline would break. Maybe they were right, or maybe the most expensive mistake in human history is the one we keep making, choosing what survives based on what is convenient, rather than what is true. We started today in a Roman palace. One man's life versus the stability of an empire. Tiberius chose the empire. The question is not how they built this, or how they knew this. The question is how many times we have made the same calculation and chosen the empire. Subscribe to Enigma Science, because what we cover next was buried even deeper, and the people who buried it were very good at their job.